we are pleased to present our very own Arthur Retnakaran.
Of all the quotes on climate change, the one that crystallizes the situation is by the French President Emmanuel Macron. By polluting the oceans, not mitigating carbon dioxide emissions, and destroying our biodiversity, we are killing our planet. Let us face it, there is no planet B. We will examine climate change that happened in the past and how it can help us how to mitigate it at the present. There are two components that interact during climate change, the living and the non-living. The relationship is inseparable and operate as a single unit. Lovelock and Margulis in 1970 came up with a hypothesis, and they called it the Gaia hypothesis. Gaia meaning the name of the Greek goddess of earth. All living organisms are inextricably integrated with their non-living surroundings to form a single self-regulating complex homeostatic system for maintaining life on Earth. The remarkable resilience of the system can withstand enormous insults, but can it survive the continuous increase in global warming? We'll examine the change in the past, the present, and predictions of in the future, and starting from the formation of the planet Earth. Let's start from the beginning. It has been sort of accepted by cosmologists that there was the big bang of an extremely concentrated point, which resulted in the formation of the solar system. There are clouds of gas and dust that are produced in the interstellar space, and clumps formed from within the cloud, and these dense clumps led to stars like the sun, and the sun formed the solar system with the planets surrounding it, one of it being the Earth. The Earth was formed 4.54 billion years ago. Comets crashed into the Earth, bringing ice, which later melted and became the ocean. Planet Theia hits the Earth. A cloud of dust is formed, which integrates to form the moon. When the liquid Earth made of lava cooled to a solid, volcanoes started spewing gases, among others, and formed the first prebiotic atmosphere. This consisted of carbon dioxide, hydrogen, helium, nitrogen, and water vapor. Now, this is the original atmosphere that was being formed. The composition of the Earth's atmosphere over its geologic history changed. When it first started 4.6 billion years ago, we had hydrogen, helium, there was ammonia and methane, there was water vapor, and there was no life. And about 3.5 billion years ago, the first sign of life appeared. These are microorganisms that's formed encrusted rock-like things because of the all joining together, and they left behind this formation. This was first discovered on Western Australia off the coast of Perth, and they called it stromatolites. And these stromatolites exist to this day. So we can trace it back all the way by dating these stromatolites. We can come up with the age of it as 3.5 billion years ago. That is the first sign of life. Now, because there was no oxygen at that time in the atmosphere, they were living in an anaerobic life. That is, they existed without oxygen. In other words, they had a very inefficient system of producing energy-forming material, and that is how they lived. But 2.48 billion years ago, the blue-green algae emerged. These are the cyanobacteria. These cyanobacteria were able to photosynthesize. They could use the sun and they could produce oxygen and form the earliest form of organic material. And that is how, as a byproduct of photosynthesis, oxygen was released. And that is how our atmosphere started having oxygen. At this time, because of the presence of oxygen, aerobic life started. In other words, they used oxygen in their metabolic system. It became more efficient. They were able to make energy-forming compounds, and they sort of flourished, and they multiplied, and they evolved. The present day, the atmosphere is 78% nitrogen, 21% oxygen, and the traces of 1% of all other gases, including carbon dioxide. Now, you'll be surprised to know that even though when you talk about traces, that 1% and that part of it is carbon dioxide, it can still have a severe impact. We will examine this and see how this happens. What is climate change? Climate change refers to long-term shifts in temperatures and weather patterns. These shifts may be natural, but since the 1800s, human activities have been the main driver of climate change, primarily due to the burning of coal and oil and gas. They produce heat-trapping gases, primarily carbon dioxide. Of course, there are other things that contribute, like methane and nitrous oxide also contribute quite heavily towards climate change. When you hear the term greenhouse effect, what we mean is when a greenhouse traps the sun's energy inside and keeps the plants warm. Now, we have this glass cage that produces the greenhouse. Similarly, around the Earth, you have carbon dioxide forming a sort of a greenhouse-like stuff covering the entire Earth and traps the sun's energy. That is the greenhouse effect. We need this greenhouse effect to keep us warm, because not all the heat that comes into us, some of that we'll keep for our own welfare. But the amount of heat that we retain is dependent on how much of the greenhouse gases we have. On the left, you see the normal amount of greenhouse gases like carbon dioxide, nitrous oxide, and methane, CO2, N2O, and CH4. And this affects us as a sort of a greenhouse kind of protection. The sun's solar radiation hits the Earth, and this keeps us warm. But some of the heat is redirected, and the heat escapes. But some are retained so that we have the warmth for us. But when you have the amount of carbon dioxide, methane, and nitrous oxide increases, more heat is retained than you have. That is the greenhouse effect. So that less heat escapes into the space. So it's a question of relative effects. One is less, one is more. Now, historically, when you look at the geological periods, there are various era, period, and epoch. We look at one epoch, the Eocene epoch, which lasted from 34 million years to 55 million years. At that time, we had a pronounced climate change. Now we'll examine and see what happened during this Eocene period. This might give us a clue as to how it happens and how it disappears and how we can use this knowledge to address the climate change at present. During the Eocene period, you find it lasted for 34 to 55 million years. The CO2 emission was primarily from volcanic activity. It is said that in the Siberian region, there were lots of volcanoes that were extremely active, and they were spewing all the gases, including carbon dioxide. And this resulted in severe climate change. And during this climate change, there was mass extinction. That's one of the primary things that happens during climate change. Extinction of species. At the end of the Eocene period, 63% of mammals went extinct. But later on, when the end of the volcanic eruption, when they all ended, and the volcanoes became silent, things returned to normal. The temperature returned back to normal. So when it returned back to normal, in the meantime, but during the climate change, many of the animals who could not adapt to the new conditions went extinct. But the existing ones, many of them survived, so it almost returned back to normal. The climate change is caused by natural causes and anthropogenic causes, that is, man-made causes. The natural causes, changes in the Earth's orbit, solar variations, volcanic eruptions, ocean currents, internal climate variability. We do not have too much control over all these things. For example, the orbit, eccentricity, changes in the orbit. Every 100,000 years, there's a little change in the orbit that increases climate change. Obliquity, change in the tilt of the axis every 1,000 years. Precession, swaying of the axis every 23,000 years. These are things over which we have no control. Solar variations, sunspots, more heat. Volcanic eruptions, many parts of the world. Ocean currents, moving cold water to warmer regions, and vice versa. Internal climate variability, sea surface, cyclic temperature changes, El Nino, which increases the temperature, and La Nina decreases the temperature. Now, these are things over which we have no control. But anthropogenic causes, on the other hand, is man-made. Fossil fuels, transport, industries, urbanization, use of that increases CO2, and as a result, there's climate change. Agriculture, animal digestion, production of methane by animals, manure, soil management, all these things contribute towards increase in CO2. Land use changes, deforestation, upsetting grasslands and croplands. Now, these are things that add to the climate change over which we have control. Now, when you look at it, and you see now, because of the industrialization and the use of fossil fuels have skyrocketed, we have the top carbon dioxide emitting countries from 1750 to 2020. The United States leads the rest with 24.5%. China is next. Russia is third. Germany is fourth. UK is fifth. Japan is sixth. India is seventh. And then there's France, and Canada is ninth. And beyond that, there's Ukraine, Poland, Italy, South Africa, Mexico, and Iran. The global greenhouse gas emissions by gas, the main thing is carbon dioxide produced by fossil fuels like coal and oil, and the industrial processes that produce carbon dioxide. Carbon dioxide also is produced in forestry under land use method, that's 11%, whereas the main thing in carbon dioxide, fossil fuel, industrial processes, is 65%. Methane is about 16%. Nitrous oxide is about 6%, and fluorocarbons that are used in refrigeration and things like that is about 2%. Now, nitrous oxide is about 6 times more effective in causing climate change than carbon dioxide. So even if it's less, the effects are severe. The comparison of warming potential, when you look at it, see the nitrous oxide is 298, methane is 25, and carbon dioxide is 1. So even though the other gases may be less, the effect is more severe. Now, non-green energy from carbon dioxide produces 63% is from coal. 33% is from natural gas and other gases. Petroleum is about 1%, and biomass is about 2%, and there are other causes of about 0.4%. And you look at the emission by sector, you find that electric power, 25%, transportation, 25%, buildings, 20%, oil and gas, 11%, coal and mining, 8%, industrial processes, 5%, waste management, 2%. These are the emission by various sectors. Now, we can also look at the percent of renewable energy. 65%, 0.5 is by hydroelectric power, and 17.7% is by wind, and 2%, very little by solar or thermal energy. And then you have geothermal, the energy, that's about 3.6%, and 13.0% is biomass. These are the renewable energy sources. This gives you an idea of the relative merits of the various systems. Now, one of the world's biggest carbon capturing machine from the air turned on in Iceland. Operators say the Orca plant in Iceland can suck 4,000 tons of CO2 out of the air every year. Carbfix processes mixes the CO2 with water and injects it at a depth of 1,000 meters into a nearby basalt rock, where it turns to stone in about 2 years, and hydride of sulfur along with the rock within 4 months. Now, we have to take this very seriously, because we are not going to get rid of all the cars and get rid of all the emissions in the near future, because they are here for a while, and it'll take a while. In the meantime, what we can concentrate is suck off as much carbon dioxide from the atmosphere by building more and more of these big machines, carbon capturing machines. The proof of the process has been demonstrated already, so we can build more, and this can be a very effective way of reducing the carbon dioxide content. Now, the green energy, what are the green energies that we have right now? The number one is hydroelectric power, because that has been a time-honored system that has been globally, and we could increase this wherever we can to produce more hydroelectric power. Then there is geothermal power, where we can get the heat from the Earth's core, and we can heat these heat pumps that we use. And these are very reliable systems. Then you have nuclear power, does not leave a carbon footprint. The only problem is the storage of nuclear waste, but we can sort of develop places where we can store this, and we can protect it from anything, disasters happening. So those are the three systems that are very reliable. The solar system we have very well developed, but unfortunately, it depends on the sun. If there is a cloud, then of course it cuts down on the solar energy. The same with wind energy. So long as there is a wind, you can get this, the energy. We still have a big problem in storing all the energy that we get. We have to rely on batteries, and our batteries still, we are very much reliant on things like lithium, and their storage unit is not as good as we should have if you want to store large amount of the energy. Now, there's effects of the climate change. The effects of the climate change is not readily apparent. Now, there's rising of maximum temperatures. Again, this can sort of change from year to year. And how do we know for sure that it's climate change that is causing it, and it's not a natural variation? Rising of minimum temperatures, rising of sea levels, higher ocean temperatures, increase in heavy precipitation, increase in the proportion of island tropical cyclones, increase in aridity and drought, loss of species, polar ice melt, and glacier retreat. We have all these things. We see them happening, like ice melt and glacier retreat, where the polar bears are unable to catch their favorite food, the seals, because they swim away in the water. They can never catch them in the open ocean. They have to wait at these breathing holes and catch them when they come up through the ice. Pacific Islands sinking, some of them are going down. But these are things that are varied, and there are people who question whether this is because of climate change or a normal sort of fluctuation. So it's always very difficult to sort of establish beyond a shadow of doubt that these are all caused by things. So we have to be careful. Now, scientists say that we can tolerate an increase in temperature of 1.5 degrees. But if it goes to 2 degrees, it spells trouble. And if it's more than 2 degrees, 3 degrees, it's disaster. So right now, we can keep it at 1.5. That's the thing we are aiming for. So anything more than 1.5 is dangerous. Carbon dioxide levels over the past million years have been traced. Like here on the bottom line, years before today, 0 to 1950. And you see early on, there's 800,000 years ago, 700, 600, and finally you come to 0 at present. For millennia, atmospheric carbon dioxide had never been more than 300 parts per million up to 1950. And see what happens in 1950. It shot up, and the current level is now 420 parts per million. So you have things were quite normal and things could be manageable, but things have become bad. And what caused this? The two main causes are automobiles emitting carbon dioxide, coal-fired power plants, and other, burning natural gas and things like that for power. These produce carbon dioxide levels over the past million years, and see how the changes that happens. Now, one of the things that happens at climate change is, extinction of species. Now, there are very many species that are threatened. Many of them are at the verge of going extinct. Now, we have a critically endangered, and species. And if you look at all these species, you have the great hammerhead shark, endangered. Blue whales, endangered. Borneo orangutan, critically endangered. Eastern gorilla, critically endangered. So you have all these species. So these things will go extinct if we don't control climate change. What should we do to mitigate the effects of climate change? First, urge governments to take bold, ambitious climate action now. This is our last chance to implement change necessary to keep warming below 1.5 degrees and avoid the most dangerous impacts of climate change. Use energy wisely. Swap your furnace for a heat pump. Install a programmable thermostat. Swap your gas stove for an electric stove. Green your commute. In Canada, transportation accounts for 24% of emissions, a close second to the oil and gas industry. Take public transit, ride a bike or share a car or buy an electric or plug-in vehicle. Fly less. Support Indigenous-led climate action. Indigenous people are well positioned to take leadership on climate because of their ecological knowledge and deep connection to the environment and experiences within climate change. Invest in renewables and install solar panels or a wind turbine. Start a climate conversation. Solving climate change requires all to work together. We can do that without finding common ground. With those who may not share our perspective, educating the public is of paramount importance. Get politically active and vote for leaders at all levels of government who take climate change seriously. Now, there are two aspects that you see, adaptation and mitigation. Adaptation is living with the climate change, making changes in your system so that you adapt to the new situation. Mitigation, on the other hand, is controlling the amount of carbon dioxide emission and reducing the thing. That's mitigating the effects of climate change. Now, if animals don't adapt, they'll go extinct. If animals adapt, they will sort of exist. Now, some animals are more able to adapt more than the others. So it depends on the situation. And you have, of course, overlapping conditions where you have both adaptation and mitigation play a role together. When the rate of CO2 production outstrips the rate of CO2 clearance, there is a steady increase in temperature, leading to widespread destruction of all forms of life, and it becomes an existential threat. In conclusion, all living and non-living components are interrelated and form a hypothetical organism, Gaia, that responds to climate change. Climate change scientists have determined that if the temperature increases more than 1.5 degrees, there will be existential threats. Temperature increase is caused by carbon dioxide, methane, and nitrous oxide, as well as fluorocarbons. Fossil fuels, coal-fired power plants, car and bus exhaust, digestive gases of cattle are some of the major contributors to climate change. Electric cars, green energy, solar, wind, and geothermal and hydroelectric power, the elimination of the use of fossil fuels such as oil, gas, and coal will reduce greenhouse effects. Since climate change is an insidious existential threat that manifests its effects over a long time, educating the public is very important. Government should be the driving force behind climate change legislation. Change is never easy, and it often creates discord. But when people come together for the good of humanity and the earth, we can accomplish great things. David Suzuki. Thank you.